Today we're really excited to have Yanchuan Sim from the LTI going to talk today. Yanchuan, or YC, is advised by Noah Smith. He's a third year PhD student, and will be telling us today about inferring political ideologies from text.
Right, thank you, Brendan. Thanks all for coming. Right, so today I will be talking about some of our groups, my work on inferring political ideologies from text. And so some of the work that I'll be talking about is our collaboration with my advisor Noah, Brian from Tapper, and also our collaborators from the political science department at University of North Carolina, Justin and Bryce. And so the first part of my talk, I'll be talking about looking at this data set of presidential candidate speeches that have been given in the 2008 and 2012 elections. And in the second part of my talk, I'll be talking about some of the current work I'm working with on text and voting data in the Supreme Court. Right. So to start, so in the 2012 campaign, Eric Fenstrom, the spokesman for Mitt Romney, he made these comments about the campaign. So when you reach so he said, well, I think you hit the reset button for the fall campaign, everything changes. It's almost like an Etch-a-Sketch, and you can kind of shake it up and start over again. So what he compared the presidential campaign to an Etch-a-Sketch, where, so for those of you who do not know, an Etch-a-Sketch is actually a toy that looks like this. So basically, kids can draw on it, and then they can sort of shake it, and the image will disappear, and they can, they have a new canvas for them to draw on again. So by comparing it to the Etch-a-Sketch, he's saying like when you progress from the primary elections in the election campaign season to the general elections, you kind of have an opportunity to sort of restart your campaign, sort of start from a blank page and start over again. Sorry, but yes. So in the presidential campaign, you can generally be divided into two parts, right? The primary election season and the general elections. So in the primary elections, candidates are basically competing within their party for their party's nomination. So they are appealing to a more ideologically concentrated voting base. And when they get nominated, they go on to the more national stage where they compete against candidates from the other parties. So in American politics, the dominant parties are the Democrats and the Republicans. Okay, right. So the motivation for a project, which is to measure the ideological shift of candidates when they move from the primary election season to the general elections. So there's a hypothesis that's in political science literature that and common knowledge that says that that tells us that candidates tend to move towards a more centrist, more towards the center before and during a general election. So like I said, in the primary elections, the voter base is more ideologically concentrated, and so candidates need to appeal to this audience. And in the general elections, you are getting votes from the entire country, so they will tend to be more centrist to gather more popular votes. Right. So in the last two elections, in 2008 and 2012, the main candidates for the general elections were Obama, McCain, and Romney. And so we want to test this hypothesis of whether these candidates use more extreme ideological rhetoric in their primary as compared to their general elections. right? Okay. So how do we conceptualize ideology? So we see ideology as a set of beliefs and values that can be recognizable as sort of recognizable. There are recognizable prototypes, right? So this is like, you have your leftists, your rights, your liberals, and so on. And so this is definitely not the only way to think about ideologies, right? In a lot of political science literature, they view ideology as sort of a continuous spectrum, but we chose to use a categorical setting in this case because it makes more sense to to think about ideological proportions, which we'll talk about later on. So for us, ideology comes in the form of a hierarchy. So you have a kind of a coarse-grained demarcation between the left and the right. And within the left and the right ideology, you have a final set of distinctions. So it looks something like that. We call this our ideological tree. And we'll be coming back to this diagram later on in the presentation. And so let's move on to, right. So this is an excerpt from a speech that Romney gave in Iowa. It's, as you can see, the highlighted words. So the highlighted words are like what we call the ideological Q terms. So they are terms that are loaded ideologically and sort of evoke certain ideologies, right? So, and in between these terms, a lot of these words are like sort of feelers. They don't they don't necessarily have to be related to ideology, which we want to sort of ignore. Okay, so the highlighted terms you see here are what our model recovered, and in a couple of slides, I'll talk about how we recover these terms. So in the way we represent these speeches, we represent it as sort of we call it a Q-lag representation, right? So between Q terms, you have what we call a lag, and the lag is basically counting the number of terms that are between consecutive Q terms. So that's the numbers you see in the arrow, and this is sort of a Q-lag representation of speeches. Right. So in the first part of this project, we split this project can be seen in two stages, right? In the first stage, we want to build such a dictionary of Q lexicon to extract those Q terms that you've seen earlier. We have already defined the ideological structure, the tree that we saw, and we want to identify prototypical examples of these ideologies, basically Q terms that sort of evoke these ideologies. And then in the second stage, I will introduce a sequence model to infer these ideological states for these Q terms in the speeches. And this sequence model should will incorporate our assumptions about these Q feelers, these Q terms and the lag, and also make use of the Q lexicon that we will learn in the first stage. So to learn our Q terms, we build them from a corpus of books that are written by authors that they are perceived as being representative of these particular ideologies. So you see here some of the books that we used. So our political science domain experts, they label these books on a title level with the ideologies according to the tree. And we have about 170 books and magazine titles, about 32 million tokens. And so from here, we want to learn. So from these books and the terms, we want to learn the Q terms, right? So on top of learning these Q terms, we want to incorporate that hierarchical nature of our ideology tree. So what our solution was to adapt the sparse generative model for text, SAGE, that was proposed by Eisenstein and Professor Eric Singh in 2011. So basically the way SAGE works is that it models the the probability of drawing a term as a log additive deviation from a background distribution. Right, so the first eta term you see is sort of like the background distribution for a particular term, and the subsequent eta terms are log weights that model the deviations between the term for the term deviation of the term from the background according to some effects. So the effects in our case would be like the coarse grain ideology, the finer grain ideology, the topics that this book are talking about, and also the content level, kind of the title level effect of the book. So I will not go into details about Sage or how we use it. So basically, we are basically just using it straight up, and we put on a L1 prior on these eta terms to get sparse effects. Right. And so these are some of the Q terms that our model recovered from the books. So this is not from the speeches. These are from the book corpus. And you see that, and you notice we only use bigrams and trigrams. We found that unigrams were not as informative, at least on a human interpretable level. And also in our validation experiments, they did not perform as well as just using bigrams and trigrams and higher n-grams. Right, so these are the Q terms that we have, and we move on to the next stage of our model. Right, so, excuse me. So as I explained earlier, we have a sequence model. So between each Q terms, each Q term is being emitted from a sequence of hidden states. So this is a typical HMM model that you see. You have the hidden states, in this case is the ideologies, and the terms that are being emitted will be the Q terms. Right? So instead of using a typical HMM with a full transition matrix, we made a couple of modifications. So one of the things that we did is that instead of a transition between ideologies, we model these transitions as a walk in the ideology tree. So in this example, to move from the sort of the right ideology to progressive left, you can imagine it as sort of taking a path in this tree. So you multiply H probabilities along the way, and you emit a term at your destination. And so what this does is that it means is that ideologies that are closer together in this tree are more likely, and it's less likely for a candidate to sort of jump from far apart ideologies. Right. Okay. If you guys have questions, you can sort of raise your hand and ask along the way. Yes.
So then is like center left just as far from progressive as far left is as far from progressive? Like,
yes.
Yeah.
Correct. But the model will learn the sort of different weights between like adjacent edges. So when it comes at the end of it, they might not have the same probabilities between different paths. So one thing you might notice is why center isn't between left and right. So as we interpret it like on a human level as like sort of center is between left and right, but but the way this is, center is not necessarily a halfway point between left and right, like in real life, right? So it's more of its own category rather than sort of a mixture of a leftist and a rightist, if that makes sense. But yeah, so we treat center as its own ideology, its own category, and it doesn't have any sub-ideology because in our ideology tree, right? Anyway, so another thing we did was to incorporate the idea of a reset button, a reset switch. So on top of just moving from one ideology to the next in a speech, between consecutive Q terms, the candidate has an option of sort of resetting. So what this means is that instead is that instead of taking a walk on the tree, what he does, he could hit the reset button and basically start walking from a background state instead. So that's a background state, right? So hitting reset, he'll jump to a background state and start the walk from the background state. Right, so this reset probability is directly depends on the amount of lag. So if you can imagine if there are a lot of filler terms between two consecutive terms, it's more likely that he'll restart and draw from and start walking from a background distribution rather than what he was previously on. So this gives the model an extra option to strengthen or weaken the Markov dependency between consecutive Q terms. Right. And then incorporating this, we want to incorporate this lexical Q terms into the model. So what we did was that we informed the emission distributions with the Dirichlet prior, which basically says that if a term is from, let's say in this case, the term social security, if this term was found in the progressive left lexicon that we learned in the first stage, we will give it higher prior value as opposed to if this term was not found in the Q lexicon, right? So, okay. So putting these things together, our learning algorithm is Gibbs sampling. We pick these latent ideology variables and the restart variables jointly for each step in the HMM. And we also have we also do slice sampling of hyperparameters in a Gibbs EM manner. So after we learn the model, we can compute these ideological proportions from the posterior distribution. Right? So basically, to measure the ideological proportion for say a particular set of speeches, we can look at for each Q term what's the probability of that ideology being associated with the Q term, multiplied by the amount of lag before and after that Q term. So that's a rough manner of measuring how much time a candidate spent on a particular ideology in his speech. So in our data, we have 21 presidential candidates and separated into the different epochs, the primary 2008, general 2008, primary and general elections for 2012. We run our model on each candidate separately with independent transition parameters for each epoch, but we share the emission parameters for each candidate across epoch, but within the candidate, right? So so as I mentioned earlier, this is how we can calculate the ideological proportion, right? So this is Mitt Romney in the 2012 elections. So for each row of this stack plot is basically the amount of the proportion that our model learns for Mitt Romney in this case for each particular ideology. And as you can see from at least in this case, from the primary to the general elections, there's a shift towards the center, towards a more balanced viewpoint between the left and the right. And then for Barack Obama in the 2008 elections, there's a general trend towards a more balanced left-right viewpoint from the primaries to the general elections. And you can see sort of the same trend for McCain. Yes. Okay. So to evaluate our model, we do not really have a gold standard data. I mean, so we are skeptical to say, that such a gold standard actually exists, right? Because ideologies and is subjective, and there are no way of saying like this guy is the left or this guy is the right, and everybody will have their own viewpoints on what it is, right? So we came up with a different way to sort of evaluate the performance of model. So what we did was that before we ran the experiments, we sat down with our collaborators and we asked them to write down a set of statements of what they would expect to see the model produce, right? So he'll write down statements that says, for example, I would expect to see that Republican candidates tend to draw more from the right ideology than from the left, and so on and so forth, right? So here are some of the hypotheses that were listed. So we have like the strong hypothesis, which basically are like sanity checks for our model that sets the lowest bar for face validity, and disagreements with the hypothesis will suggest flaws in our model, and we need to go back and look at what we are doing, right? We have more moderate hypotheses, which are hypotheses that that match the intuition of our domain experts, but that disagreements suggest that more examination of either the model or the hypothesis is needed, right? And so in total we have about 13 different hypotheses on different parties and candidates, and we evaluate our model with other baseline models based on the number of such hypotheses that it matches or not. Right. So we compare our model against different simplified versions of the models. Right. So one of which is the traditional HMM model, where you have n-square transitions without using the ideological tree structure. We have a model where you never ever restart, so you do not have the restart switch. So this is akin to the HMM model with just the ideological tree, but weaker Markovian assumptions. And then you have one where you always restart. So in this sense, you can think of it as sort of a mixture model where each Q term is independent from the other. So our model performed really well on this hypothesis, although for one of these sanity checks, it placed candidate John Edwards slightly on the right. He's a Democrat, leading to the wrong sanity check, which happened for all of the models actually. So we see that the ideological tree was useful in encoding our prior knowledge of these ideologies. Although this ideological tree may not be a perfect representation of the ideological space of some ideological space, but we can imagine more complicated structures, trees with more hierarchy that take advantage of this model. So it doesn't actually have to be a tree. It could be a graph. It could be network with a broader ideological spectrum. Right? So similarly, we can also see that the comparing between the always restart and never restart options, the restart switch is useful in helping to smooth out these transitions. The model can automatically learn when it should restart or not. And it allows the model to sort of weaken the Markov dependencies when it needs to. Right?
Are these models nested?
Sorry?
Are these models nested?
Nested.
HMM could have learned your tree structure, yes?
You can decompose the HMM to learn the tree. Not necessarily. There's it's a one-to-many mapping, right? From a full HMM to a tree.
That's what I'm trying to ask, because your model's on the one on the left here.
Yeah, clip.
And so is it possible that the HMM model could have generated exactly the same output as the model you did?
Yes, it could, but it would. Yes, correct. Yeah. So our model's output would be a subset of possible outputs of the HMM.
I think the way to think about it is
But
It's not, they're the same model, they're just parameterized differently.
correct.
So the HMM has more,
Yes, n squared.
It should probably be called something like our model minus the tree structure, because it's just a classical parameterization of the transitions.
Right,
So in any model you can represent with CLIP, you can represent with the classic parameterization, but it's not as constrained, so it's not as likely to discover the same. You could say the CLIP is more biased, right?
Yeah, so CLIP basically encode these assumptions where closer ideologies are more likely, further ideologies are less likely, and you basically only have linear number of parameters.
And similarly with the reset button, you estimated how frequently the reset button gets hit?
It's a Poisson distribution based on the amount of lag between consecutive terms.
But you estimated that the intensity of that process?
Yes.
So it's possible it could have been, the outcome of the model could have been we never reset?
Yes, definitely possible. So there are some speeches where a reset doesn't ever happen because the entire speech is basically on the right side of the tree or the left side of the tree. Yeah. So a couple of conclusions that we can draw from our model is we have shown how we can learn these Q terms without a lot of human effort. Basically, we just labeled these books on a title level, actually on a chapter level, and then you taking what we learn, the terms that we learn from this book corpus, we transfer it to our speeches to learn ideological proportions quite successfully. We also propose a different framework for evaluating these models using what we call preregistered hypothesis. And so we suggest that this could be an alternative form of evaluation for NLP applications, especially in social science, where you often do not have a gold standard data readily available or easily defined. So if you are interested in looking at sort of the outputs from our model from different speeches and the different terms, you can check it out on our website. Right? And so that's for the first part of my talk. In the next part of it, are there any more questions from this part? Yes.
You said you tested it for 21 candidates or something?
Yes. So.
I'm wondering what the overall patterns were. They were consistent with those 3 examples.
The overall pattern, they are consistent. So that's what the hypotheses are testing. So like for example, in the for like the subsequent hypothesis, there will be like you have, for example, in this first P1, for example, basically we test for each candidate whether they draw more from the left in the primary compared to the. Actually, only for 3 candidates they have a. So, but the only 3 candidates have a primary and general elections, right? Because most of the primary candidates get kicked out and they do not participate in the general elections anymore.
21 weren't like third-party candidates.
Yeah. They were the 21 candidates from the Democrats and the Republicans mostly. Sorry for the confusion earlier. Yeah.
I think like a different number of hypotheses with different models.
Yes. So the total number might not match up because some of them are not statistically significant. So if they are not statistically significant, we drop them off from the total number. Yeah. Right. Yes, Matt.
How do you know that the model or that these politicians are expressing an ideology versus attacking an ideology? Because, for instance, in a primary, the opponents that a politician will be addressing share their ideology,
right,
broadly. Whereas in a general election, the opponents that they're addressing or countering in their speeches don't share their ideology. How can you be sure that your model is capturing things they're expressing and not things they're attacking?
So the model wouldn't be able to differentiate that, but you would expect a candidate to espouse more of what he believes in than to spend more of his time talking about what other people are talking about. Hopefully, we know that that's not always true, but yes.
Some anecdotal evidence, like I've run a topic model over the 2008 campaign speeches, and for Barack Obama, the most consistent, the topic he uses most frequently has words McCain and Senator.
Right.
Uh,
Oh, so we do,
it's very frequent.
yes.
The shift could easily be explained by someone shifting to attack an ideology that they're opposed to.
Right, so we actually see that happening. So one of the pre-processing steps we did was to get rid of all names in these speeches.
But they still talk like Senator McCain supports X ideology, right?
Right, yeah, so, right, so the model may not be able to recover that, but yeah, it
Can I jump
can,
in with a
right,
comment?
okay.
So the model here is actually taking an incredibly cynical view of politicians' speeches. The model does not believe, I'll voice it from the model's point of view so that it's separating myself from the model. The model does not believe that there's propositional content expressed in these speeches. The model literally views Mitt Romney as saying keyword, some stuff, keyword, some stuff. And he's just throwing these keywords at him. And it views the keyword as being associated with an ideology. Whether he's talking about it in a positive light or making a claim that's counter to or whatever, none of that is obviously captured here, right? But the underlying assumption is that just by virtue of cueing those ideas, he's, what's the right word? He's speaking to or evoking a particular ideologies. Now, it might be that he's using negation, and but likewise he said, we're sort of assuming that more often than not, they're going to cue the things that they want to express.
That's fair. I'm
Yeah.
wondering about the particular conclusion that people shift. Is that caused by an actual change in the ideology they're espousing, or the ideology they're countering? And
We don't differentiate that.
We don't
It would be
differentiate,
interesting
yeah.
to try.
Right, so I'll move on to the next part of my talk. I would like to talk about some of my, what I'm currently working on of the Supreme Court. It's very much work in progress. I do not have hard results, but so I want to take this opportunity to present this approach and solicit comments and recommendations from you guys. Right, so right, okay, so let's go into it. So this what I'm working on is a utility model of modeling Amy Curie in the Supreme Court. I'll give a quick 30-second overview of the Supreme Court, right? A very high-level overview, right? They do a lot of complicated stuff. So there are 9 justices in the Supreme Court, U.S. Supreme Court, right? So there's a petitioner who submits. So when the Supreme Court agrees to hear a case, there's 2 sides, so the petitioner and the respondent. So they will submit their own briefs and reply briefs, sort of to espouse their arguments and why the justices should favor their side or not. And on top of the 2 sides, there are also what we call the amicus curiae briefs, which are submitted by third parties who are not directly related to the case. So this could usually advocacy groups, unions, individuals, the U.S. government in the case through the Solicitor General. So who are these? And so the justices, make decisions based on all this information that they receive during the oral argument and so on, and they make decisions, and so they vote on a decision that favors one side or the other, or sometimes their decision do not actually favor anyone, right? So what we are interested in is in the amicus curiae. So you ask, who are these people, right? So it's basically Latin for friends of the court. So they are third parties with no direct relation to the case, but they file briefs, sort of provide a broader information to the justices to advocate for or against a particular interpretation of the case at hand. So U.S. law is a lot based on precedents. So if a certain precedent may have broader implications for other people that are involved that might not be directly in this case, but might be associated. So for example, in the antitrust case between the American government and Microsoft in the 90s, other companies that might be affected by similar rulings would be like the telecommunications company. They might submit amicus briefs to support one side or the other because having a precedent would have implications for themselves, right? So these amici, they seek to further their own agenda. And so how could we incorporate this knowledge into a model, right? So the motivations behind studying this problem is one is does framing of this, when we write this brief, how we frame these arguments affect the justice's decisions? If so, how does it affect it? We want to perform counterfactual queries. For example, what if the Electronic Frontier Foundation did not submit briefs in the software patent cases? Will we have more restrictive patent laws? And also, we want to empirically validate against hypotheses in political science, Supreme Court literature regarding the Supreme Court and how they make decisions, right? So in like a lot of the work I've been working on, we assume that we already have so this is a very high level overview of what I'm working on. So there's no math beyond a couple of symbols, right? So you can imagine we have a black box, a generative model that generates text from these cases, basically briefs that are submitted by petitioners and respondents. You have text written by these different amici who are more or less independent. And you also have votes that are the outcomes of these cases. Like each justice will basically vote on whether they support a certain stand or not. Right, so in a typical generative model, you have this data likelihood, you generate these observed variables given some parameters. Right? And so as an amicus, when I file a brief, I decide how I want to write this brief, right? So delta, in this case, you can think of it as a latent representation of this text when I write my brief. So when I write my brief, I have and I submit it, I have a preference over what I would like the outcome to be, right? So in this like utility, expected utility kind of framework, this preference would be a higher score if our side wins or get more votes, or a lower score if not, or something. It can be arbitrary. So basically the expected utility I would gain from writing this piece of text in this manner as described by delta would basically be the expectation over all possible vote outcomes, right? So there are 9 justices, there are 512 different possible vote outcomes, right? And for each of them, I have some preference, and I can find the expected utility, right? So when I choose to write this text, I'm basically trying to optimize my expected utility, right? So I would choose delta that maximizes this value. So the delta that we observe in the text, this delta might be latent, but the delta that we see from the data our assumption is that it maximizes this utility that this amici has done, right? So in this sense, we have a generative story that describes how our data is generated. And on the other side, we have this individual amicus curiae who have their own selfish agenda to maximize their own utility. And so in taken in the limit, you can also say that this expected utility, the first order conditions would be that this expected utility go towards 0. And so we incorporate this as a constraint in the model and optimize it like any other optimization problem. And so actually that's the end of my slides. Yeah. And so this is our approach to the problem. And so far, preliminary experiments have shown slightly better accuracy in predicting votes. But predicting votes is not the only thing we want to look at. But still very much at early stage. This is more of introducing this model and this approach to this problem. Yeah. So actually, that's the end of my talk for today. Thank you. So any questions?
So, what should be the relationship between, like, the text of the case and the amicus brief? Is it that you say things similar to what the outcome would be, or is it, I don't know?
Text of the briefs and the case.
Yeah, like what model are you? How do you incorporate that model? Or do you think it should be analyzed?
Right, so right now we are building our model of ideal points model. That's very popular in political science literature.
Yeah.
So basically imagine justices are points in some multidimensional space, and cases are points in some multidimensional space, and justices vote according to how close or far away they are from the points. So you can, so you can think of these amicus curiae briefs as sort of adjustments that move the. In our model now, we see them as these briefs as amicus as trying to move the justices, but you can also see them. Depending on how you model it, you can move the case, you can move the justices, and so on. Yeah.
I wonder why you limited the first study to just the last couple elections when it seems like you could have a lot bigger sample size than 3 if you tried to expand out over time.
Right. So this is more of a data availability issue, I think.
Wait,
Right, so-
I think it's really interesting, but
Yeah.
I'm just wondering whether you can really test that hypothesis.
So that's-
with 3, the sample size is 3, I guess.
Right, so that's something that can be done, but you'll definitely need a lot more hypotheses. And so at least in this paper, we work with just the last 2 elections, because there's also when this move towards the center, Etch-a-Sketch thing became really popular. Yeah.
So your hypothesis is that it might not even hold for
Right.
these elections because it's like a popular strategy that
It's so.
came about recently.
So this hypothesis has been around for a while, right? So yeah, I guess you could probably run it on more data, and you might be able to see results that agree on probably not, or maybe not agree with this, what we have found. And we did not do that experiments, yeah. So of course, there are a lot of experiments that can be done, but this is the set of things that we've chosen to do, given our constraints.
So thinking about espousing versus opposing, could you run semaphore onto some relation extraction system and see things like relations involved, instead of keywords, have key relations, where you get people actually expressing opinions about something, about a particular topic? You think that would work?
Yeah, so you would have basically, you would have words that evoke topics, and you also have words that evoke, that basically evoke opinions of these topics, I guess,
I
in a
guess
sense.
the minimal change,
Yeah.
it seems, is
Just-
replace the keyword with a triple that says I support or I oppose or something like that that's extracted from semaphore.
Yeah, that's something that can be done, I guess. And in that sense, what you would learn is basically relations that are Q relations, basically, like relations that evoke certain ideologies. Yeah, that makes sense.
It's more like propositional content.
Right.
Right,
You have-
which will tell you whether or not someone is espousing an
at least
ideology or not.
at least some of the keywords seem like they're concepts that you might believe in or not believe in.
Yes. Possibly.
Just a thought.
Even basic relations,
Yeah.
or semantic relations like that could be, you could still have the same problem, right? Because they could be nested inside
Yeah.
a non-factive modality, right?
That'd be less common.
Well, you're assuming that,
That's
maybe. I could say,
Or
that,
some sentiments, maybe.
I mean, so Ideograms gets a little bit of this. So I saw repeal Obamacare was one of the bigrams when we went through that slide. So that's a very different content than just Obamacare.
And even just saying Obamacare is
Yeah.
pretty indicative.
Yeah, it is indicative, but repeal Obamacare is more so. But then you might say, you could wrap it further, you could say oh, bad people are trying to repeal Obamacare. Yeah, so,
Yeah.
But Obama would.
The working assumption is that someone who was pro-Obamacare would probably not even use the phrase
Yeah.
repeal Obamacare. They would find a different way to say it.
Like
Obamacare.
over.
Well, we don't use, I don't know if YC said this, but there are no unigrams.
Right.
This model only uses bigrams and trigrams.
I see.
And
So
programs.
it's- So we avoid a lot of the sort of, we avoid
Yeah.
some of the word.
But wouldn't that also be just picked up in the distributions in the first place? Like if the liberal distribution is going to have some Republican things in it, but they're just going to get a lower rate. Right? If you're opposing something,
So-
we can
So this
Yes.
this is why we use the model we use to pick the keywords, to try and control for that.
No, I'm saying it's going to get somewhat at like what's the distribution of saying things against the Republicans versus pro.
Yeah.
One minor question. It sure looked like Obama in the general election in 2008 had more red than blue. Was I seeing?
Yes, that's true.
So
It's
would
like-
you see that a false hypothesis?
Only if you think he's not conservative.
No, I mean, was it on the sanity
Right.
checks that they should use more blue than red because he's a Democrat? And you said that wasn't
Right.
true for John Edwards, but not for Obama. So
So,
your S3, doesn't Obama fail that one?
so then we're going to draw from the left. Wait. So, this for this hypothesis is the general elections draw.
It's actually S2.
So red
But
is
I was looking at the general election side.
Yeah, but he's,
yeah.
the hypothesis is should draw more from the left than the Republicans.
For that's from primary candidates actually.
Yeah, but S3 is general, and it's more from the left than Republicans.
So in
It's not
S3
from the
is
left.
from Democrats between Democrats and Republicans, not relative to themselves.
Why not? Shouldn't it,
It's less right than McCainism.
Yeah, it's less right. Okay.
shouldn't
So-
S2 also hold for the general election? That seems like a sanity check to me. Why isn't it?
So in the general elections, you only have one of each candidates, right? It's
But still a Democrat
So-
supposedly should draw more from the left than from the right.
so one
And it
thing you
doesn't
can say is that the model doesn't. So it's the identifiability issue, right? Like it can be a lot of right. Like in a particular instance, you can have a high proportion of one thing versus the other, but what the model is, so you can only look at so the relative differences are those that matters, right? Like the individual.
In the general election, you're not.
Yeah.
You're trying to win the majority of voters. So most of the voters are conservative.
And that's the other thing too.
He's saying conservative things.
Okay,
Just maybe less so than Republican.
okay.
Yeah.
So actually, I think this was one of our moderate hypotheses. In the 2012 general election, Obama should sample more from the left than from the right, and should sample more from the left vocabularies than Romney. And we claim in the paper to have gotten it right. So I'm not sure.
That graph was 2008, I thought. Not-
Oh, this
2008,
is,
yeah.
8 on the, yeah, this is all 2008, right?
Yeah.
So we should be clear that it was Justin who wrote down the hypotheses.
And it was written before he saw the
We should
result.
ask him.
Yeah. It's.
Yeah, that was
I wonder with your pre-registered hypothesis, if you used one of the sites where people like pre-register hypothesis before, I did completely answer it, but I know like there's a
Sorry.
movement in psychology, right, to start
Yeah.
pre-registering hypotheses online so that, you know, there is some official record before you actually get their data analysis. And clearly I believe you, but I'm just wondering if like that you took that step or if that's something you suggest for this kind of new method of a gold standard.
I mean, in some
Right.
sense we did, right? Because these all exist in our email, timestamped or in some document somewhere.
Yeah, in some sense, these hypotheses are not sort of they are like sort of tuned for this model, like they are specified for this model, so there are like mathematical descriptions of what they expect to see.
Yeah, I'm just
Right,
wondering
so-
about like whether like you think there should be some visibility to this
Oh.
process, right? Like, because some person could come along later and say we pre-registered these, but they're really post hoc. and now
Right.
we see that. And I'm just wondering like if you think that should work into like the kind of the, gold standard criteria.
Yeah, ideally that should be the case.
It's hard to make other people do
Yeah.
things.
No,
At
but this
least-
is a big thing in psychology
Right,
because there have
yeah.
been so many scandals basically about bad
And
post-cognitive
medical
analysis.
research as well.
And
I mean, this is why pre-reg is such a big thing now.
at least, yeah. I think in our case, our hypotheses are based on, hypotheses that are already popular in the literature. So there are citations and references to these hypotheses, and we're just adapting it, for our model by describing it in a mathematical form. So it's not that much of an issue, I think. Yeah.
Yeah, I mean, this methodology is not common in our research community, and in fact, I was expecting when we put it in for review that people would object to it.
I mean, you're the first paper to do this, I think.
No, you just said it's happening in
No,
psychology.
in
No,
these
it's just
computational
different,
social
yeah.
science worlds.
Okay.
And that's different. That's about it's not like the way that you're doing it at all. Right?
Yeah, so I think in terms of whether it should be just sort of trust us, this is what we did, this is our methodology, we're telling you like most research is, right? People could always lie about anything, and this method is susceptible to that. That's kind of one thing, like just saying this is what we're going to do, and if you don't trust us, well, you don't trust us about anything. There's a different issue, which is should there be mechanisms that make it impossible for people to cheat? And that's kind of fascinating to think about, but I don't think that was critical to us
No,
or to
yeah.
convincing our reviewers.
Well, I think
Yeah,
the way
that's fine.
to think about this is a lot better than the traditional way to evaluate a topic model, which is post hoc.
How do you evaluate? There's a traditional way.
Now, the traditional way, you look at the topics, and 3 of them look like something cool. And so this is way more rigorous than that. And but it has the advantage of that method does, you can investigate very qualitative things. You don't have to have a quantitative gold standard, 1,000 labeled documents. That's what's kind of nice about this approach.
What's impossible to do would be to register your hypotheses before you actually ran this analysis.
We
It's
did
not-
that.
No, but you can't. I can't know if you registered these hypotheses at a website. I
Right.
don't know that you have not already done this study.
So basically, we should have put them on Twitter.
But
Yeah.
before you actually gather the data,
Yeah.
but there's no way to know. That's different from a psychology study where you register hypotheses and then you run the experiment, and then the experiment happened in September of 2013 because there's the people. So it's like a
Chicken bake.
falsifying a thought experiment. Where's the term gold standard come from, by the way? Why does it show up so much more in computer science than it does in economics?
Bretton Woods.
You guys, we've been on the gold standard since 1970 something or other.
Like all good ideas from economics, Brian.
You've been hanging on to the old ones, yeah.
All right, we have a meeting now.
Don't get me started on improvement. He was outrageous today.
What did you say?
Do you disagree? No, but I don't think it should be quite so. He took two papers on a reasonable level. Yeah, I like your remarkable.
Yeah, pre-registration. Some sort of earlier, write down your hypothesis before you look at the result.
If any idea where these cardboard boxes usually go, maybe out in the kitchen or something. Pretty sure it might be in the kitchen right here. You haven't seen it, have you?
No. Somewhere.
I'll be right back.